Number 3, the stepped Ohm's law. So what is the Ohm's law? You look at the definition of the Ohm's law. Refer to the, you can just look at the equation V is equal to IR. So the Ohm's law take the V, or potential difference across an electrical device, is proportional to the current flow, and if it must have a constant temperature, right? Or the V proportional to the I when the T is or temperature is constant. And number 2, what is the effect of increasing temperature on electrical resistance? So when the temperature or T increase, the resistance in the metal is also increase. This is because of the atoms vibrate with greater amplitude when the temperature increase. Well, if you look at the equation, R is equal to R naught 1 plus alpha change of temperature. Sorry, this is not the delta. This is initial temperature T. So now if you look at the equation here, the R and the T is proportional. And number B, figure show the circuit with the 3 resistor R1, R2 and R3 connected to the 12 battery, and calculate effective resistance. To calculate the effective resistance, you first consider the R1 and R2, because R1 and R2 is a series, meaning the resistance R1 and R2 is 4 plus 15 ohm, meaning this is a 19 ohm. Right? So, and the next is if you combine R1 and R2 compared to the R3, this is parallel. So meaning the total effective resistance here is this is 1 over combination R1 and R2 is 19, and R3 is 7. So if you calculate the value of the R effective or total resistance here is 5.12 ohm. And the total current flow, now you calculate the total or effective resistance of the circuit. So meaning if you look at the equation, V is equal to IR. R here is effective resistance 5.12, and the voltage is provided by the battery is 12 volt, meaning you can find the value of the current flow. I here is equal to 2.34 ampere. So this is current flow in the circuit. And number 2 is rate energy supplied by the battery. So the rate energy supplied by the battery, you can refer to the equation. P is equal to V squared divided by R. The value of the V is equal to, you can refer to the battery here is 12 volt square, and R, you know, the value of effective resistor here is 5.12. So now the power or the rate of energy is actually the rate of energy. This is E divided by T, energy divided by the time T. So this is equal to power. That's why we calculate the power, meaning the meaning of the rate of energy is P. So now the value of the rate of energy is 28.1 watt. So the EMF E is defined as energy provided by the battery or dry cell, say, that flow charge through the external R or internal resistor in the battery. This is a EMFE. Number 4.2, a battery with the EMF and internal resistor R is connected variable to resistor. The current in the circuit 0.5 ampere when resistor set 19.5 ohm, and when the resistor set to 24.5 ohm, the current reduced 0.4 ampere. Calculate EMF and internal resistor R. So you have the two situations. The first situation is the resistor and the current flow, and the second equation you have a different value of the current and internal resistor R. If you look at the equation, I external and internal resistor R, so meaning you have the two value of the R and I. So the first situation, I current flow is 0.5 and the external resistor is 19.5. The second situation is resistance R increased 24.5 ohm and the current flow is 0.4 ampere. Meaning you have the two equation here, equation 1 and equation 2. So from the equation 1 and equation 2, you can find the value of the E and internal resistor R. So the final answer, EMFE is 10 volt and the internal resistor is 0.5 ohm. Number B, this is the figure 5. So the figure 5 show the 3 EMF. You have a E3, E2, and we have another battery E1. And the value of the E1, sorry, E2, E3, and R1, R5 is, you can refer to the question here. So the question asks you to calculate what is the value of the E1 and the value the current flow I1 here. Now, so we can start from using the Kirchhoff law. Well, the first Kirchhoff law is total I in is equal to total I out. If you look at the diagram here, this is the current I1 and I3 and I2. So now you can use the first Kirchhoff law. You can start from the I2 because the I2 is combination I1 and I3, meaning I2 is I in and I out is I3 and I1. This is the first equation. To produce the second equation, the third equation, you can find the second Kirchhoff law. Total EMF is equal to total drop voltage IR. So start here, you can draw the loop. This is the first loop. And let's say this is the second loop. So to produce the first and second and third equation, so the first loop here, we start from the E1. Okay, continue the loop here. So we have same to the direction I1, and this is the direction of the loop to the left and direction of the current flow I3 to the right, meaning you must have a negative drop voltage I3 times resistor here is 5 ohm, and we have another battery here, but this is positive and this is negative, meaning the opposite direction to the loop. So you must have a negative value of the E2 is 2 volt. So now back to the E1, so meaning you have a second equation, right? So the third equation is come from the loop 2. Loop 2 start from the E3. E3 is 0.5 volt and continue. This is current flow here is I2. This is I2. Because direction of the loop and the I2 the same direction, so drop voltage here you have positive I2 times resistor 3 ohm, and continue you have a battery here, so this is positive and this is negative, meaning direction of the battery and direction of the loop is the same value, so positive This is to vote, right? To vote here. And continue, you have drop voltage R2. The current flow here is a I3. This is I3 through the R2, so meaning you have positive I3 and R2 is a 5 ohm. So this is a third equation, right? So now you have a first equation, second equation, and the third equation. I think you can use your own calculation. This is mathematical process, and the final answer, you can find the value of the I1 is equal to 0.46 ampere. Actually, you can find the value of the I2, and you can find the value of the I3, but the question asks you to calculate the value of the I1 and battery E1, right? Battery E1 is a 1.3 volt. So this is the two answer asked by the question. So, and that's all. Thank you.